Okay, so yesterday we learned about margin of error, and today what we're going to focus on is creating and interpreting a confidence interval. The hope here is that you'll know how to, you'll know the steps to creating a confidence interval, and that you'll be able to use varying levels of confidence to solve the same problem and come up with different confidence intervals for the same thing. Alright, so first of all, let's talk about what a confidence interval is. A confidence interval, and note we're going to talk about it in terms of mu, so that the probability that the interval contains the population parameter mu is C. Note C is the confidence level, and we know mu to be the population mean. We're going to define some variables here real quick, and it should only just take a second. This is what your confidence interval will look like. You're going to be using x bar minus e is less than mu is less than x bar plus e. What you notice is this variable and that variable are the same, as well as the e's. The only difference is I'm taking a point estimate, like x bar, subtracting the margin of error, and then taking that same point estimate and adding the margin of error. Remember, x bar is your sample mean. It's used to estimate the population mean. Mu is the population mean, and that is a parameter. It's a parameter versus x bar, which would be called a statistic. Capital E is the margin of error. It is calculated by doing sigma divided by the square root of n. But this brings up the question of what is sigma and what is n? And hopefully you know this, but just to clarify, n is your sample size, and sigma is the population standard deviation. This is also a parameter. Well, we actually rarely have the population standard deviation, so often we use S, the sample standard deviation, as an estimate for sigma. So S is our sample standard deviation. We'll use it to estimate sigma. Again, parameter, statistic. Parameter, statistic. We're going to use our statistic to help create an interval or a range of values that may contain the actual population parameter. Alright, with confidence level we need to know that most often we'll be using these three confidence levels. They all have a z sub c of 1.64, or they all have a z sub c. The z-score of a 90% confidence interval will be 1.645, 1.96 for 95, and 2.575 for 99. That actually brings me to an error that I had back here. I should have margin of error. I should have a z sub c right there. Sorry. One mistake. Alright, now let's look at a problem. So we have a problem here where we're looking at repair costs of washing machines. As we work for a consumer advocate agency, and we're trying to find the repair costs that we can talk about. So let's look through the problem and identify what our numbers are and what variable they represent. So if I see this, I know that I randomly selected 40 repair costs. The mean was 120. Sample standard deviation is 1750, and I want a 95% confidence interval. Well, I can immediately fill in some of these. I know that n is 40. I do know that the mean of the sample, so that's x bar, is 120. I know that my confidence level is 95%. Okay? And that's really all I'm given right there. Later on it does ask me to do a 99% confidence interval. The only difference will be that we'll change that to 99. Now going back one slide, I can see that a 95% confidence interval has a z sub c, or a z-score of my confidence level, that's that variable, of 1.96. That goes right here. Okay. So now essentially, oh, and I forgot, I do have my 1750, not for this, but I'm going to use it to estimate sigma. It actually is S. So now I've got to find out my margin of error so that I can perform this function here. So I'm going to set up the equation. E equals 1.96 times my sigma, which I'm going to use S to estimate, 1750 over the square root of 40. Note, if you're putting this in your calculator, make sure you put parentheses here. My margin of error for this becomes 5.42. That's just a little plugging this expression into my calculator and seeing what it equals. Okay, so now I've got margin of error of 5.42. Now it's simply saying, can I take this 120, and I'll use a different color here. A little indecisive on the color, and now I didn't even click what I wanted. Let's go with green. Alright, so I'm going to take my 120, and I'm going to subtract 5.42. That's going to be less than mu, which will be less than my 120 plus 5.42. What I find is that I get 120 minus 5 is 115 minus another 42, so that's going to be 114.58 is less than mu is less than 125.42. This is my confidence interval for mu. One other note, guys, is that you could write the confidence interval like this. You could write 114.58, comma, 125.42. These are two different methods to writing a confidence interval. The function here is very much the same, so I'm going to go pretty quickly through it. We're going to have E equaling a different Z sub C. So if you go back one slide again, we're looking at 99%, so 2.575. Times 1750, because our estimate of sigma will not change, and our sample size didn't change. This is going to be 713. You can check that on your calculator. Now, what I notice is in order to increase my confidence, my margin of error has to be bigger. I have to allow for more mistakes if I want to be more confident that the population parameter will be within my interval. So now if I add and subtract that, what's going to happen is I'm going to end up with 112.87 is less than mu is less than 127.13. Sorry, that was a terrible 3. 127.13. The conclusion here is that you know that 95% of the time you take a sample, if you took 100 samples, that you could expect 95 of your confidence intervals to contain the population parameter over here. If I took 100 samples, different samples, I could expect 99 out of 100 to contain the population parameter here. And that is how you construct a confidence interval.